Climb dog, climb dog. I want to teach right now. Right now. I want to teach right now. 6-4 vectors and dot products. All right. Dot products. I barely even knew her. I don't know what that means. Anyway, what we're going to be doing today with 6-4 is finding dot products of two vectors and using the properties of dot product. We're also going to be finding the angle between two vectors and determining whether two vectors are orthogonal. Try saying that 5 times fast. We're also going to write vectors as the sums of two vector components, and we're going to use vectors to find the work done by a force.
Luke, use the force, Luke. Luke, I'm not your father.
Who named your kid Luke anyway? No offense. Alright, so let's look at our introduction here. The dot product yields a scalar rather than a vector. So a scalar is just a number. It is not it's not a vector. It is a number. So the way to find your dot product is if you have two different vectors, a vector u and a vector v. What you're going to do is you're going to take your u1 times your v1. So u1 times v1. And then you're going to take your u2 times your v2. And then you're going to add those together. This will eventually give you a scalar or a number. Okay, that's what your dot product means. So there are some properties of your dot product down here. Basically, you know, distributive property u dot v plus w means you have to do the dot product of u and v and dot product of u and w. 0 times your vector means you get 0, and so on. So let's find the dot product for each of these components. So if we're going to find the dot product for A, what we're going to do is we're going to take 3 times 2, and then we're going to add together 4 times -3. So that just gives us a 6 plus -12, which gives us a -6. That was difficult. So we get a -6. Notice it's a scalar. It is not written as a component form. It is not written in terms of I and j. It is a scalar. It's just a number. So let's look at B. Here we're going to take 2 times a 1. Okay, got to multiply your x components. Plus 2 times a -1. So in this case we get a 2 plus -2, which is just equal to a 0, and that 0 will actually have greater importance here when we move past example 1. So example 1 shows us how to find a dot product. You multiply your horizontal components together, then you multiply your vertical components together and add the two numbers.